Hi everyone, welcome to the April 2023 Maths Advanced lecture for Year 11. My name is Krisha and I'll be taking you through today's series. So let's get started. So I am obviously part of ATAR Notes, so I'm just going to give you a little intro to ATAR Notes as a company. So we've been around for a while and we've had our online, well actually our in-person lectures since 2016. So 2016 to 2019, we were running our lectures in UTS in the holidays. Then 2020 hit and we moved to our online lectures, which were a big hit, bigger than we even were in person because we were able to reach a lot more people. Um, and this time, we're trying something a little bit new. We're trying out pre recorded lectures. So I am not actually talking to you live at the moment. I recorded this a couple of weeks back, but do not fret. There's a Q&A section down the bottom. I am actually there right now, like actually answering your questions just typing instead of verbally. So still ask as many questions as you want, and I'll be sure to answer them all. A little bit more about ATAR Notes is that we have a bunch of free resources. So obviously, you've got the free lectures, which you're at right now. We've got discussions, like our forums, our monthly newsletter, and something else that we're quite known for is our ATAR calculator as well. We have a bunch of resources that's all for free for you guys. But if you were after something a little bit more, we've also got our own like paid resources as well. So as well as ATAR Notes, I am one of the tutors for the ATAR Notes like tutoring system, which is called TuteSmart. So I do the Maths Advanced for the HSC, and I do private tutoring for a lot of subjects, including Year 11 maths. So if you guys are interested, I think there'll be something probably down below about that as well. We've got our study guides, which is probably something that we're just as popular and known for as our holiday lectures. And then we have this resource called Ed Unlimited. And Ed Unlimited is kind of a little bit of a rock star in that it actually has all of our study guides put into like a website. Pretty much it's Netflix, but for the HSC. So that's also something that you could probably take a look at. There'll probably be a few discount codes down below as well for you to take a look at. Okay, and before I properly get started with this lecture, I'd also like to give a massive shout out to our sponsors, because if it weren't for them, these holiday lectures wouldn't be occurring. So thank you to them. Um, Also, before I properly get started, I'd like to, before I even introduce myself, give a shout out to you guys. So you guys, number one, have taken the actual effort of getting up, getting onto your computer and watching this lecture right now. So that's a shout out to you in itself. But also, I'd like to congratulate you on completing your first term of year 11. I think that's like year 11 is definitely a big jump from year 10, and you've already conquered it. So a big congratulations to you guys for that. You're a third of the way there already, which is kind of scary, but also super cool. So good job on that. So I'll quickly introduce myself. I graduated in 2021 with an ATAR of 95.85. The subjects that I did include Maths Advanced Extension 1, Chem, Physics, DT, and English Advanced. Um, Currently, I do veterinary science at USyd, so I'm second year. So if you have any questions about that, you can also pop that down in the questions below. I am, you can tell by my degree, a huge animal fanatic. I do love to rescue and foster animals. I Ro- ugh. I foster a lot of kittens at the moment. I've got a little foster kitten. I'm not sure if he'll make an appearance today, just because if he does come into my room, he'll probably be biting down the camera and everything. So we'll see how it goes. Another fun fact about myself is that I absolutely love rock climbing, but I really cannot say that I'm very good at it because I don't have the strength for it, but I still really enjoy it. Okay, so just an overview of what will be happening today, what we'll be going through. So there's going to be two like content blocks that will kind of be smushed together because we're like doing a whole new like method of presenting to you guys. Um, and I know that this isn't a live stream that we had like last term in the Christmas holidays, but I'm still here to respond to any of your questions down below. So ask me literally anything. Nothing is a stupid question, and I am more than happy to answer. Okay, so all of this is brand new content for you guys, which you haven't encountered, and it's perfectly okay to be lost. I definitely was when I was in your position, and I know the content that you'll be learning. Even Year 12 students are lost with this content as well. So today will be pretty much just an intro to calculus. So the actual content blocks, we'll start with just some frequently asked questions because even though the Q&A is down below, I just wanted to address questions that I get asked all the time. Um, Followed by something that I like to call the art of solving questions. Pretty much just a method of maximizing your marks so you don't make silly mistakes. Something that I started to use a little bit later in my HSC journey that I wish I'd known earlier. So I wanted to get you guys started nice and early. We're also going to start with differentiation, and then we're going to go and break it down into all of the like differentiation rules. Most of these rules would mean nothing to you yet, but don't worry. In under 2 hours' time, you shall know it all. Okay, so let's get started. Okay, so frequently asked questions. The first one that I get asked a lot is how much time should I spend studying maths each week? How much time should I be studying for all my subjects altogether? Um, so for this question, I unfortunately can't give you a hard set answer. Um, sorry. Um, For me, it would look a little something like I would come home after school and I would do my maths homework. Like, unless I didn't have maths that day, the first thing that I would do when I come home is my maths homework. Um, After that, I would mark my maths homework and then see if I got anything wrong. Whatever I got wrong, I'm not just going to be like, oh, I got it wrong. Okay, next question. I'm going to take a look and say, why did I get it wrong? What did I do to get it wrong? Um, Even if it was some dumb, silly mistake, I want you to kind of reflect upon why you got it wrong. Because just that process of being like, hang on, take a step back. What did I do? That's going to stop you from making the same mistakes repetitively. And until you do that reflective process, you will keep making that mistakes because you won't actually know what you did wrong, right? So that is how you should be doing your maths. But in terms of time, I didn't really study for maths during like the Monday to Friday week unless I was struggling with what I was learning in class. So let's say we were learning about the quotient rule, and I was like, this is absolutely disgusting. I'd probably do a few more questions on it. So whatever my teacher sent me as homework, and then some more after that. Um, and then at the end of the week, I would spend a good chunk of time just going through everything I learned in this past week, maybe even a little bit of the harder stuff that I did the week before. And then I'd also come back to something that I've been struggling in for a while. So that's how I studied for it. In terms of time, I don't know, I kind of studied for advanced extension one kind of smushed together, but combined, I would spend at least 6 hours a week excluding homework. But yeah, and how much time should you be studying for all your subjects altogether? Obviously, that depends on how you're feeling about your subjects, what you're struggling with, and all of that. But the advice that most teachers give is a general rule of thumb is an average of 3 hours a day. Take that with what you will, because everyone studies differently. Your methods, your time, the way that you do it, all different to each person. So I unfortunately can't really give you a straightforward answer, and I can only give you a beat around the bush kind of answer. Um, Second question is what did studying for maths look like for you? I kind of answered that a little bit in my explanation for the first question, but yes, as I was saying before, starting off doing my homework, marking my homework, reflecting upon what I got wrong, Another good thing that I personally didn't utilize, but one of my friends did, and she found it really helpful, is like a mistakes diary. So get like a little book, and anytime that you make a mistake, you're gonna write, the date that you did it and what mistake it was. So that, once again, just that whole reflective process of what did I get wrong? Why did I get it wrong? What should I do next time to not get it wrong? I mixed up my quotient rule, I mixed up my product rule because you don't know what they are yet, but they're quite confusing. They're not really, but they're really easy to be confused with each other. Um, so something like that, so that you don't keep making the same mistakes. Apart from that, studying for maths, as I was saying before, was end of the week, I would reflect upon what I'd learned in my 4 lessons throughout the week, and then I would go back to what I learned last week. And then I can't think of an advanced maths like example, but for all your extension one students that just learned permutations and combinations, um, I'm going to guess that you found it just as disgusting as I did, which was truly atrocious. And it stayed that way for a while. So literally from every holidays, Easter holidays of year 11 until the September holidays of year 12, every single holidays I would set aside like a good day to go through questions and like make myself super strong at that. So that's like, I can't think of an advanced example at the moment off the top of my head, but anything that you guys are finding hard, and like you just can't wrap your head around, end of the week, that's the time to really do it. End of next week, go again. And then in the holidays, now that you're in the holidays, anything that you like, take some time to just go back and look at what you've learned this term. Anything that you're just a bit like, oh, I forgot about that. Oh, I can't quite remember how to do that. Oh man, I got this wrong. Um, Take a moment to just relearn that. Relearn that, do the exercise again. Um, and that is really going to strengthen your whole game, your whole maths game. Okay, but yeah, math for studying for maths looked a lot like doing exercises and then past paper questions when it came to that reflective end of the week or end of the term kind of thing. Okay, I didn't get the best marks in my term one assessment task. Should I drop to standard? This one, I'm going to guess a few of you guys would have already asked by this point. Um, and the answer to that obviously isn't going to be like, yes, do it, or no, don't do it. Um, but I personally would not drop to standard unless it's because you're not enjoying advanced math. If you haven't learned calculus yet, wait until your school's started calculus for you to kind of um, know whether you should drop to standard or not. But I don't know if this is a popular or unpopular opinion, but in my very fine opinion, apart from the fact that calculus is in maths advanced, but I enjoyed and like found calculus quite easy, I think standard maths is even harder than advanced because there's a lot of like wordy questions and applications questions that I personally suck at. Um, so don't drop to standard because you think standard's going to be easier. Drop to standard because you don't like the content that you're learning here, and take a look at the standard content and be like, is that better or is that kind of just as terrible? That's my little piece of advice for you. Don't drop because you like got bad marks. Um, Fourth question. I know all the techniques and content, but I am so prone to making silly mistakes. How can I fix this? So now that's what I'm going to go into, a little something called framing, aka what I was talking about before when I said like the art of solving a question. So, as I was saying before, this technique I only started utilizing at the very end of my HSC journey. So pretty much before trials, like my HSC trials, I was getting good marks for sure. I was like maybe average 90s, like low 90s. And then once I started applying this, I was getting in my practice papers like 99, 100%. And in my trials, I think I got like 99%. So it's just going to stop you from making dumb mistakes, not fully reading the question, not fully answering the question, accidentally making a mistake somewhere in your working. So something that I personally would advise you guys to use. So the steps that you go is number one, read the question and read it again. Underline, highlight, whatever you want, the information in the like the key variables. So your X, your Y, what is impacted by what. Okay. Look for hidden information in the questions. Um, I'm trying to think of a year 11 example. Mm, okay, well, I can only think of a calculus example, which you guys can't relate to just yet, but you will once you finish the lecture. Um, but something like, what's the rate of change of this, and that? The rate of change is another way of saying, like, looking at the first derivative. So when you differentiate, aka use calculus upon, um, you need to like kind of understand that the rate of change is also the first derivative. And until you make that connection, you can't actually answer the question, right? Because it assumes that you're going to use the derivative to answer the question. And the third question is, what does my final answer need to look like? You know, do I need units? Do I need to round to sig figs? Do I need to find the actual area? Do I need to just write that x is equal to this, or do I need to like actually work everything out? Okay, just so you don't overdo your answer and accidentally lose a mark because you didn't give your final answer correctly, or just in case you underdid it and they actually wanted you to show all your working, right? The second thing is to recall the relationships and formulae that are required. So the differential rules that we'll be learning later on, for example, um, and then the actual methods and steps to getting to the final answer. Okay, and you're actually going to write down these formulae. So if you think that you're going to need to use the chain rule, you're going to write down the like equation for the chain rule so that like straight from the formula sheet or whatever is easiest for you to remember. And then step three, you're going to solve methodically down the page. And then you're going to actually check that your answer makes sense. Why? First, making sure all info makes sense and is correct. Then the formula is written correctly and check each step after is actually making sense as well. Then after that, just make sure you go back to your step three in your first step, which is what does my final answer need to look like? Does it look like that? Okay. Um, this, I know it's four steps and I explained it in quite a bit of time. But when you're actually applying framing, it will really only add maximum 30 seconds to your time. Like once you get to once you've practiced it enough, it's just your first nature and it won't take any extra time. So just something to keep in mind, and it's really going to like make your silly mistakes go extinct because you can't do silly mistakes with this kind of thing. So yeah, just something that I would like you guys to use if you wanted to. Okay, now in terms of actually studying for maths, there are a few methods to study for maths, obviously. One that I started to use once again a little bit later towards my HSC journey is mind maps. The reason being is because you're able to take a look at the big picture um, through these little dots. So you connect them everything together, and I'll show you a picture. This is an example of a calculus mind map. A lot of these words might not mean too much yet, but I've got my calculus in the middle over here, and then it branches off to differentiation, it branches off to integration, applications of differentiation. And then from each bubble comes another bubble and another bubble and another bubble, which all branch off into their own bubbles. And then they can branch together to like form a connection. So that's just how you can, big picture see your work. And then if you're not a big fan of the bubble mind maps, you can also do a hierarchical map. So big picture calculus. Breakdown from calculus, we have differentiation. Breakdown from that is the product rule. And then breakdown from that is the method of solving the product rule, which is the cross method solution. Okay. Once again, this might all be a bit gibberish for you at the moment because you can't use my calculus examples, but we'll get started with calculus now. Okay, So let's start off with differentiation, which was all we'll do this whole 2-hour lecture. So as I was saying a couple minutes ago, is that the differentiation basically describes the rate of change of one variable with respect to the other. Okay, the method that you actually derive an equation gets you the gradient of the function. Okay, obviously of the original curve. Okay, the derivative is the, oh my gosh, this is so hard to explain. The gradient function of the original curve is known as the derivative, um, which is the gradient function. Yeah. Okay. I'm gonna give you a bit more less wordy stuff in a sec. Okay. So the derivative function measures the rate of change of the gradient at any x value. So yeah, okay, I'm not going to bother with any of this, but I'm going to go into this. So the actual notation to write your first derivative is f dash x, y dash, or dy dx. Okay, so let me get my pen out. Well, let's take a look. So I'm sure most of you guys would be quite familiar with the notation of like f of x is equal to blah, blah, blah. So the way that I can write the first derivative is f dash x is equal to blah, blah, blah. Okay, so the first derivative is just one dash. Okay, then we have these notations. Pretty much, you know how we'll write y is equal to blah, blah, blah. You can write y dash is equal to blah, blah, blah. Or if you want to be super fancy, dy dx is equal to blah, blah, blah. So basically, if I'm going to actually describe dy dx to you, it if you're going to say it in words, it will be the like the rate of change of y with respect to x. So the y is at the top, so the rate of change of y with respect to x. This is some more high level stuff that you can go a lot more into. Probably not today, but maybe not even in year 11. Definitely when you get a little further in year 12, though. Okay, next slide. Okay, so as you know, and you've learnt already, functions can be either continuous or discontinuous. Okay, continuous functions have, no discontinuities, so they have no holes in the graph, no asymptotes, and they have no jumps, right? Um, so yeah, it's important to actually note whether or not there will be any discontinuities, because the function does not exist at the point where there is no derivative at the point. Sorry, there's no derivative where the function doesn't exist. Okay, let's go into differentiation by first principles. It's a little bit of a complex formula. I will explain it to you guys. But this little rule will get you the first derivative of any basic function. Okay, so it's f dash of x is equal to the limit of h approaches 0 of f of x plus h minus f of x all on h. Okay, I think we've got an example in the next slide. Okay, here we go. Find the derivative of f of x is equal to x squared plus 4x plus 4. Okay, so I'm going to write the formula up for you. So f of x is equal to the limit of h approaches 0 of f of x plus h minus f of x all on h. I'm going to give you a second to try this on your own. I don't expect a lot of you guys to actually know how to do this, so don't fret. Okay, just for the interest of time, I'm gonna get you to pause the video if you're not yet done, work through it, and then come back and take a look at my working, okay? So let's change my pen color because I don't like red. Let's go to orange. Okay, so I'm going to sub everything in. So f of x is equal to the limit of h approaches 0. For those of you wondering why it's the limit of h approaches 0 and why you can't just make h equal to 0, it's because of the denominator down here. If h was equal to 0, then anything on 0 is undefined if you chuck it into your calculator, so it just won't work. So that's why it's the limit as h approaches 0. And I'll explain why we even bother doing that in just a sec. So let's first use this example to explain it. So let's do f of x plus h. So that will be x plus h squared plus 4x plus h um, plus 4. So that's f of x plus h minus f of x. So minus x squared plus 4x plus 4. Okay? And that's all on h. So let's expand things out. So that's x squared plus 2xh plus h squared plus 4x plus 4h plus 4 minus x squared minus 4x minus 4 all, oh, that was an ugly line, all on h. I'm going to change my pen color and we're just going to take out any, like cancel anything out that can be cancelled. So 4x can be cancelled, so can x squared, and so can 4. Okay, so let's rewrite this to make it look a little bit prettier. So it's equal to the limit of h approaches 0 of h squared plus 2xh plus 4h on h. Now what I'm going to do is I'm going to put h out the front as a common factor. So lim h approaches to 0 of h plus 2x plus 4, all on h. Now what I can do is I can cancel these h's out. Okay? So it's equal to the lim h approaches to 0 of h plus 2x plus 4. But now I don't have the problem of the limit of h approaches 0, because if I make h equal to 0, nothing's going to, um, you know, explode. My like function won't be undefined anymore because I don't have h in my denominator. So let's just make it equal to 2x plus 4 because I can get the h to equal to 0. So my final answer is therefore f dash of x is equal to 2x plus 4. Okay, hopefully this process makes sense. I think we have another example in the next slide. No, we don't. Never mind. But I'm going to get you guys to take a look at this original function. Here it is. And now let's take a look at the derivative function. It looks kind of similar. Maybe, maybe not. But I want you to take a look. We have a 4 and we have a 2x. And I'm just going to leave you with that at the moment. So I'm going to actually explain the general rule for taking the derivatives. And that is when f of x is equal to x to the power of n, where n is any number, then the derivative is f dash of x is equal to n times x to the power of n minus 1. Okay, so let's do our example of y is equal to x squared. Then y dash will be equal to, so n is equal to 2, so I can bring my power out the front, so n times x to the power of 2 minus 1. So it'll just be equal to 2x. Okay? Um, but yeah, you're going to bring out the power to the front and then reduce the power up the top by 1. Okay? Um, and then the derivative of a sum, um, so f of x is equal to gx plus hx, will basically, all you need to do if they're being added together is you're just going to individually differentiate everything. Going back to our original example of y is equal to x squared plus 4x plus 4. Okay, I'm going to give you a quick second to try and differentiate that on your own, just using that rule that I just introduced you to. Okay, let's, oops, so annoying. Cool. Okay, so let's do the x squared first. So it will be bring the power out the front. So 2 times x to the power of 1 plus, we have an invisible 1 over here. So it'll be 1 times 4 times x to the power of 0. Okay. And then for just the 4, we have an invisible x to the 0 already. So what I'm going to do is I'm going to have it like 0 times 4 to the x to the negative 1. So my overall differential will just be 2x plus 4. So that is another method of doing the differential. Okay? And you can see it's a lot less working and a lot easier as well, less time consuming. Okay, then we have the derivative of a multiple, which I've kind of already showed you in the derivative of 4x. If we have some constant out the front, then the constant itself won't be differentiated, the coefficient. So the example of y is equal to 4x, the 4 itself will just stay the same. So it'll be 4 times the derivative of x, which will just be 1. So it'll just be 4 times 1, which is 4. Okay, so the actual coefficient stays the same. Okie dokes. Well, okay, so here are a couple of examples. So y is equal to x cubed plus 3x squared plus 5. Take a look at the power and the coefficient that's brought out the front. Okay, so the 3 over here, oh, yellow's a bad color. Let's pick a different color. Let's go purple. The 3 over here is brought out the front, and this reduces to 2. Okay, the 3 out the front over here is just a coefficient. We're going to keep it out the front. So it'll be 3 times 2 times x to the power of 1. Okay, and then 5 has an invisible x to the power of 0, so it's being times by 0, which is why the 5 just disappears. Okay. Um, okay. So then we have the example of this one, which I find a little bit annoying sometimes when we have the a half out the front, because you still need to think of it as though it's any other number. So the a half is still brought out the front, and then a half minus 1 gets you negative a half. So it's 1 on 2 times x to the negative a half, aka 1 on 2 root x. Okay, the x squared we've done a couple times, and then the 2 just disappears. So yes, you just vanish. Okay, so let's do these two examples. So differentiate the following: y is equal to x squared plus 7x plus 5. And then we have a little bit of a tricky one. We have f of x is equal to x to the negative 4 plus 2x to the power of a half minus 3x. Okay. And also, yeah, just a quick note. You only need to differentiate by first principles when specifically asked. So the question will be like, differentiate this using first principles. That's when you use it. It's something that can be assessed in the HSC. It'll only be one question if it is asked, but obviously you want to get as many marks as you can, and it is a big part of year 11 prelims. So I would recommend doing a little bit of practice on differentiation by first principles as well. Okay, but yeah, otherwise just use the basic rule that I just went through. Okay, I'll give you like 30 seconds more to do this question. Okay, let's get started. So for the first question, I'll just rewrite the actual question. So y is equal to x squared plus 7x plus 5. Okay, so I'm going to separate them out. We'll do x squared, we'll do 7x, we'll do 5. So y dash will be equal to, we're going to bring the power of 2 down the front. So it'll be 2 times x to the power of 2 minus 1. So just 1. So plus 7, the coefficient stays out the front, times, we have an invisible 1 over here, so we're going to bring the 1 out the front. 1 times x to the 0. Okay, then we have our invisible x to the 0 over here, so it'll be plus 0. So our y dash will be equal to 2x plus 7, and that's the final answer. Okay, so that's for A. Let's do B. For B, so f of x is equal to x to the negative 4 plus 4x to the a half minus 3x. So f dash of x is equal to, let me make that a little bit smaller. This comes here, this comes here, this comes here. Okay, so I'm going to bring negative 4 out the front. So the negative also is included in my power. So minus 4 times x. Guess what the power is going to be this time? If you guess negative 3, unfortunately, that would be wrong because negative 4 minus 1 is equal to negative 5. Okay? Plus my coefficient of 4 out the front times by my power of a half. times x to the a half minus 1, which is minus a half. And then we're going to bring the minus 3 times 1 times x to the 0. So it'll be minus 4x to the minus 5 plus a half on 2. Well, sorry, 4 on 2, which will be 2x to the negative a half minus 3. And that is my final answer. Okay, hopefully this process made a little bit more sense now that we've gone through a couple of questions. Okay, now let's go into finding the gradient. So we're actually going to start applying differentiation now. Okay, so once we've actually learned how to differentiate, we can now differentiate to find the gradient at a certain point on the curve. The derivative, as we were saying before, is the gradient function, okay? Because we can sub in any x coordinate and we'll get our like y dash value for that specific x, okay? So subbing in the x coordinate into the derivative, so y dash or f dash of x, will result in the gradient at that specific x coordinate. Okay, I'm going to show you how to do A because it's going to be a bit tricky if I just like say, do it. And then I'm going to give you a sec to do B by yourself. Okay. So A, y is equal to x squared plus x minus 6. Let's do y dash. Y dash will be equal to, so x squared, we're going to bring the 2 out the front. So 2x to the 1, so just 2x, plus x to the power of 1, which bring the power down and then subtract 1 by 0, which will just give me 2. Plus 1. And then the minus 6 disappears because we're Thanos. Okay, so at x is equal to 2, y dash is equal to 2 times 2 plus 1, which is 5. Therefore, the gradient at x is equal to 2 is 5. It's quite simple, right? Okay, I'm going to give you a minute or so to do B by yourself. Okay, let's go through this second question. So find the gradient on the curve y is equal to x squared minus 5x plus 4, where the gradient of minus 3. This is tricky because it's actually the inverse of what we just did. Okay, so B, y is equal to x squared minus 5x plus 4. I'm going to make my y dash function. So x squared becomes 2x, minus 5x becomes minus 5, 4 disappears into the ethers. Now, what I'm going to do is I'm going to say at x is equal to what will make y dash equal to minus 3, right? And now I need to solve for that. So 2x minus 5 is equal to minus 3. So let's do our reverse algebra. Let's change the color to yellow again. I'm going to plus 5, plus 5. So 2x is equal to 8. X is equal to 4. Now, I'm just going to recheck that because just in case I made a mistake. So let's sub x is equal to 4 into y dash, and I can just write check. Y dash is equal to 2, 4 minus 5. And you can see that I did indeed make a mistake. So let's redo that. So minus 3 plus 5 gets me to 2. So x will be equal to 1. Now let's check that again. Check um, sub x is equal to 1 into y dash. So y dash will be equal to 2 times 1 minus 5, which is indeed negative 3. Therefore, gradient, or if you wanted to be a bit fancy, you can write mt. So the gradient of the tangent is equal to negative 3 at x is equal to 1. Okay? So that is how you can approach a question like this. I have another question for you guys to do real quick. Okay, so down below, tell me what the answer is. If y is equal to 3x to the power 4 minus 2x to the negative a half plus 3x plus 1, then what will y dash be? I'm going to give you a few seconds to do that. Okay, hopefully everyone's had a chance to answer the question below. Um, if not, I'll give you a sec to pause the video and have a go. But I'm going to get started. So y is equal to 3x to the power 4 minus 2x to the negative a half plus 3x plus 1. So y dash will be equal to 3 times 4x cubed minus 2 times minus a half x to the minus. So what's minus a half minus 1? That's equal to negative 3 on 2 plus 3 times x to the 0. So just 3 times 1 plus 0. So that's going to get me to 12x cubed minus minus, right? So that's going to get me to plus x to the negative 3 on 2 plus 3. Okay, so that answers my question to C. So anyone that got C, good job. It was definitely a bit tricky, especially with the double negatives. Okay, now let's get into the rules that I was talking about earlier. So, if we're given a function y is equal to u times v, where u and v are two different functions. So let's say an example would be like x minus 2 2x plus 3. So two different functions being times together. Um, then we can use a rule to differentiate this, and that is called the product rule. So y dash will be equal to v times u dash, so the original v times the derivative of the u plus the original u times the derivative of v. Or it's given this notation, which is the exact same equation, just written in a different method. And this is the way that the formula sheet writes it. But I personally, to this day, use this one because it just looks a bit nicer, right? But let's use an example because both of these, let's face it, look absolutely disgusting. Oh, okay, we don't have an example. Let me write an example then. My question to you guys is y is equal to, let's use my example from before. X plus 1, 2x plus 3. That's my example. I'm going to give you, actually, no, I'm going to actually show you how to do it because it's a bit of a tricky rule if I do say so myself. I'm going to define my u and my v. So u will just be my first function because I'm not fancy like that. So it's equal to x plus 1. U dash will be the derivative of u, right? So it will just be 1. V will be equal to 2x plus 3. V dash will be equal to just 2. Now, obviously, for this kind of example, you can use FOIL and just expand, but there will be many examples that you'll pass where expansion won't really help, and you'll still have two separate functions being times together. So it's really important that you actually learn how to use this rule. So let's follow the y dash rule. So it'll be v times u dash. So this times that. So it'll be 1 times 2x plus 3 plus u times v dash. So like that. So it'll be 2 times x plus 1, which gets me to 2x plus 3 plus 2x plus 2. So my final answer is 4x plus 5. That is my final derivative. Okay? Awesome. Okay. Now let's go into the chain rule. Statistically, the chain rule is the most like the pretty much the bane of most HSC students' existence. It's the one that people most get confused on, and I'm not sure why, but as people head towards the HSC, they kind of just forget this rule exists. So my mission today is to make it as nice for you guys to understand as I possibly can. Okay. But basically, it's when we have a whole function to the power of n. So instead of it just being like x to the power of n, it's going to be some disgusting function that we'll call f of x, right? All to the power of n. Okay. So the derivative of that, so d dx, we'll take the function out the front just like we do for the simple differentiation. So it'll be n times f of x to the power of n minus 1. So far it's like exactly like our x to the n kind of formula, but in bigger version. But the next thing is something that we need to do that's not in the x version. And that is we also need to times by the derivative of what's inside this function. So we're going to also times by f dash of x, which gets us to, n f dash of x, f of x to the power of n minus 1. Okay, I think there's an example in the next slide. Yeah, we'll use that example in a sec. Let's do this one first. So my question for you guys is f of x. Oh, we'll just go y to make life easier. Y is equal to 2x squared plus 1 to the power of 4. I'm going to give you a second to try this one on your own because it is quite similar to our x to the power of n1. And I have a feeling you guys will be able to do this on your own. So I'll give you a minute. Also, I probably should have told you in the start of the lecture, the reason why I'm barely looking at the camera is because my computer's over, like I've got type my writing pad down here and my screen like over here. So I like never look at the camera. Sorry, I've got an external camera on. So I apologize if I'm like barely making eye contact with you guys. But yeah, let me get started with the question. So let's define our f of x. F of x. Actually, let me do it in a different color so that we're not confusing it with my like explanation up the top. We'll go back to yellow. So f of x is equal to 2x squared plus 1. So my f dash of x, using our basic differential rule, gets me to 4x. Okay? So y dash will be equal to n, which is the power, so 4 times f dash of x, so 4x, times f of x to the power of n minus 1. So the original f of x, so 2x squared plus 1 to the power of 3. So my final answer is 16x, 2x squared plus 1 to the power of 3. Okay? I hope that made sense. We'll go through another example real soon as well. Okay, so the chain rule is used for composite functions. So I kind of went through this already, but it's also known as a function of a function rule, okay? Which I think there might be another explanation. Never mind, no explanation. I'm going to give you a second to do this question on your own because it's simpler than the one that I went through before. And I also believe that you guys can do this on your own. While you guys are going through that, I actually want to explain to you that the x to the power of n rule still follows the chain rule example. So let's do x squared. Okay, so y is equal to x squared. I'm going to set my f of x to just be, what's underneath the power. So it'll just be x. So f dash of x is just equal to 1. So doing my like plain example, my y dash will be equal to bring the power, not the flower, to the front. So 2 times f dash of x, so 1 times f of x, so just x to the power of 2 minus 1, so 1, which leaves me with just 2x. So even the simpler rule is just the chain rule again, but a little bit nicely done because x's derivative is just 1. Okay, and that will nicely lead us into the explanation for this question. Differentiate y is equal to x minus 4 to the power of 10. Let's define our f of x. So f of x is equal to x minus 4. So f dash of x is equal to just 1. Okay, so let's do our final y dash, which will be equal to n, so the power, which is 10, times f dash of x, which will just be 1, times f of x, x minus 4, to the power of n minus 1, so 10 minus 1, which gets me to 10 x minus 4 to the power of 9. So see, it's a disgusting looking rule, but honestly, it's not that bad, right? It doesn't, I think it's very much overhyped in the negative way. It's very much, I can't say underhyped. I don't know what the negative version of overhyped is. But yes, it is that word. Okay, now I have another question for you, which is also the chain rule. So y is equal to 2x squared plus 5x minus 3. I'm going to give you a minute to do this one on your own because it's a little bit more tricky, but it's actually the exact same thing. So take a sec. Okay, you'll probably need a bit more time, but just so that we can get everything done in time, I'm going to get you to pause the video if you need some more time and then unpause to take a look at my working, okay? So let's go through this question. So let's define our f of x, which is whatever's inside the brackets, right? So x squared plus 5x minus 3. So we have f dash of x will be equal to 2x plus 5. All right, now let's actually do our y dash. So going back to our original rule, when I said that we have a constant times a function, the constant itself, the coefficient, isn't being timesed. So the 2, it just chills out the front. And we're going to times that by our n, so 4, times f dash of x, so 2x plus 5, times our f of x, so x squared plus 5x minus 3, all to the power of n minus 1, so 4 minus 1, which will be equal to 8, 2x plus 5, x squared plus 5x minus 3 to the power of 3. And that's my final answer. I suppose if you wanted, you could expand out the brackets for this. But honestly, if you're leaving things in simplest form, this is as simple as it gets. So that is what the HSC would want you to do. Okay? All right, let's see if there's another question. Because if I'm going to get you guys to do that one in a sec, I want to write another question for you guys though. So my question for you is differentiate the square root of x cubed plus 2x plus 1. Okay? I'll give you a sec to do it. Yeah, okay, I'll give you 30 more seconds and then I'll get started. Okay, shall we get started? I think yes. So I'm going to actually rewrite this. So most of you guys would know a little bit of your index laws from year 10. Um, so this can be rewritten as x cubed plus 2x plus 1 all to the power of a half. Now from here, I think you guys would be able to solve it. So f of x is equal to x cubed plus 2x plus 1. So f dash of x is equal to 3x plus 2. So my y dash will be equal to my n, which is a half, times my f dash of x, 3x plus 2. Let me rewrite that because that's gross. 3x plus 2 times my f of x, x cubed plus 2x plus 1, all to the power of n minus 1. So a half minus 1, which gets me to a half, 3x plus 2, x cubed plus 2x plus 1 to the power of negative a half. Now, if I'm going to write this in my best mathematical manners, because they didn't give me to the power of a half and stuff like that, they gave me in my square root form. So I'm going to do the same thing. So negative a half power is basically 1 on root blah, blah, blah. So the way that this can be rewritten is, a half times, we'll go like this so that I can visualize it a bit better for you guys. So it's 3x plus 2 on 2 times 1 on root x cubed plus 2x plus 1. Okay, so my final answer will be 3x plus 2 on 2 root x cubed plus 2x plus 1. And that's my final answer, okay? Now I have another question for you guys, and that is to differentiate y is equal to x minus 4 to the power of 5 times x minus 5. Okay. Um, Heads up, this might take a couple of rules from what we've learned already. I'll give you a sec to try this one on your own. Okay, just for the interest of time, I'm going to get you guys to pause this video if you're not yet done and you want to give it a go. And I'm going to get started on the working. Okay, so let's define our two functions. So I actually need to use the product rule and the chain rule for this. The product rule is the big rule that I'll need to be using though. So I'm going to define my two functions, my u and my v. I always pick u to be my first function and v to be my second function, just because it makes a bit more sense and it'll help you in doing it that way for the quotient rule, which will be the next rule that we learn. Okay, so, oops, why does that keep happening? U is equal to x minus 4 to the power of 5. So u dash, using our chain rule, will be 5 times x minus 4 to the power of 4. And then f dash of x inside the function is just 1, so we don't need to times anything else. Our v will be equal to x plus 5. Our v dash will be equal to 1. So keeping in mind that y dash is equal to u dash v plus v dash u. Let's give this one a go. So it's going to start off with this cross. So it'll be 5 x plus 5 x minus 4 to the power of 4 plus this cross. So 1 times x plus 4 to the power of 5. Okay, now I'm going to take out a common factor of x minus 4, oops, x minus 4 to the power of 4, which leaves me with x minus 4 to the power of 4, which leaves me with 5, x plus 5 plus x minus 4. Okay, so that leaves me with x minus 4 to the power of 4 times 5x plus 25 plus x minus 4, which leaves me with x minus 4 to the power of 4, 6x minus plus 21. Okay, and that's my final answer. I'm actually just going to chuck this out the front because I like my power function to be at the end. That's just my personal preference. You can leave it as the line that I just did though. 6x plus 21 times x minus 4 to the power of 4. And that's my final answer. So it's definitely a little bit more disgusting than the questions that I've given you so far, but it's still achievable, right? I'll give you another example. Here we go. So if f of x is equal to x squared minus 5 times x plus 1 to the power of 7, then find f dash of x. I'm going to give you a minute to try this on your own, okay? Okay. For those of you that would like to try this on your own, I'm going to get you to pause. So I'm going to get started. So let's define our two functions, because as you can see, it's two functions being multiplied together. So I'm going to define my first function to be u. So u is equal to x squared minus 5. U dash, oops, u dash will be equal to, so x squared becomes 2x, negative 5 becomes minus 0. My v is equal to x plus 1 to the power of 7. In this case, my f of x is equal to x plus 1. My f dash of x will be equal to 1. So v dash will be equal to 7 x plus 1 to the power of 6. So my f dash of x, using my equation of y dash is equal to u dash v plus v dash u, gets me to 2x x plus 1 to the power of 7, because I'm timesing by this cross first, and then I'm going to make this cross, which will be plus 7 x squared minus 5 x plus 1 to the power of 6. I'm going to take out a common factor of x plus 1 to the power of 6 like I did last time. And this is just simply because I want to simplify it as much as I can. So x plus 1 to the power of 6 times 2x x plus 1 plus 7 x squared minus 5. Okay, simplify further. 2x squared plus 2x plus 7x squared minus 35. X plus 1 to the power of 6. 2, nope, 9x squared plus 2x minus 35. Okay, I'm trying to think, maybe this quadratic could be simplified. So let's take a look and see if it can be simplified. I don't actually know. I haven't done this question before. So what we'll do is, You can choose which method suits you best. I think I might just use the quadratic formula. So x is equal to minus b plus minus root b squared minus 4ac on 2a. Okay, that gets me to minus 2 plus minus 4 times 9 times negative 35 on 2 times 9. Let's take a look at what the discriminant is. Okay, it's not going to be a nice number because my discriminant is like minus 2 plus minus 35.55 on 18. So I'm actually just going to leave it like this because this is the simplest form that I can get it to. Okay, awesome. Okay, now the next question is for you guys to try on your own. I'm only going to give you maybe 30 seconds to try this one because it's been on the slider poll for a while now. So yeah, 30 seconds. I'll come back at an hour 17. Okay, let's get started. So for this, I only need to use the chain rule. So what I'm going to do is I'm going to define my f of x, or I'm going to put it like in quotation marks because it's just my mini f of x in this case, right? So it'll be 5x minus 3. So my f dash of x is equal to just 5. So my grand scheme f dash of x will be equal to the 3 that's coefficient at the front that we can't do anything to. So 3 times n, so 7, times f of x, sorry, f dash of x, times f dash of, oh my gosh, times f of x, so 5x minus 3 to the power of 7 minus 1, 6. That's going to get me to whatever 3 times 35 is, 105. 5x minus 3 to the power of 6. So anyone that got D, good job. All right, now let's go into the quotient rule. So basically, this is when we have a function being divided by another function, okay? So pretty much like the opposite of the pretty much the opposite of the product rule. Yeah, so the notation that is a bit nicer to learn is this one in red, but the one that's in the formula sheet is this thing, which just looks absolutely atrocious, but it's just a disgusting way of writing exact same thing. So the method that I'll be showing you, since they're both the same thing, will be the same, but the actual equation that I'll be showing you will just be this one to make your life a bit easier. Okay, let's go into an example. So differentiate y is equal to x minus 2 on x plus 7. I'll work through this one with you. So I'm going to first just write the equation. So y dash is equal to u dash v minus v dash u on v squared. Okay, that's all it is. So let's define our u to be x minus 2. U dash is equal to 1. V is equal to x plus 7. V dash is equal to 1. So we'll go y dash is equal to u dash v. So x plus 7 minus v dash u, x minus 2, all on v squared. So x plus 7 all squared. Okay, so the main thing that I want you guys to keep notice of is that we've got a minus over here. So the actual ones that you times first actually matters, because if we put v dash u in front of u dash v, then you're going to be getting the complete incorrect answer. So it needs to be on this diagonal first and then this diagonal, and only that way. Awesome. And now we're just going to simplify further, which gets me to just 9 on x plus 7 squared. And that's my final answer. Okay. Um, I have another question for you. So this one, I'm going to get you guys to try on your own. I'll write the equation up again. So y dash is equal to u dash v minus v dash u on v squared. I honestly don't even, I mean, yes, please remember this, but I always find the v's and the u's so confusing to like remember which one goes first. So I always, obviously, I'll write down what u is, I'll write down what v is. U is always the numerator, v is always the denominator. And then just remember the crisscross that goes like this, only in those two directions. So the first criss, the second cross. Okay? I'll give you a minute to try this on your own, because I would love for you guys to be able to confidently, independently do the quotient rule before your class even gets to it. Okay, I'll give you like 90 or so more seconds. Okay, I'm going to get started now. So anyone that isn't yet done, please just pause the video and then keep going once you're ready to see my explanation. All right, so let's define our variables. So as I was saying before, the numerator will always be u. So u will be equal to x cubed. So u dash will be equal to, bring the 3 out the front, subtract by 1. So 3x squared. V will be equal to x plus 1. V dash will just be equal to 1. So I'm going to write my dx, which is just the same way of writing y dash, or what was my other one? F dash of x. So we're going to do this cross first. So 3x squared, x plus 1, minus 1 times x cubed, all on x plus 1 squared. Okay, so that's going to get me to 3x cubed plus 3x squared minus x cubed on x plus 1 squared, which gets me to 2x cubed plus 3x squared on x plus 1 squared. I'm going to take out a common factor of x squared from the front, so it'll be x squared 2x plus 3 all on x plus 1 squared. And that's my final answer. Okay, hopefully that wasn't too bad. And I'm going to move on to um, pretty much the last section of like what we're going to be learning today before we go into like study tips and stuff. So we're going to go into the notion of what is a tangent to the line and what's the normal, which a lot of you guys might not even know of. The tangent to the line is basically we have a line like so, and we're given a specific spot and we want to know what the tangent is. It's basically the instantaneous gradient at that spot. So it'll look like this. It'll just be a straight line that just scrapes it, touches it only once, the actual curve. Okay? And the normal is pretty much the gradient, except it's perpendicular. So 90 degrees to the tangent. So it looks like this. So you would say that this is the gradient of the normal, and you would say that this is the gradient to the tangent. Okay? So we know the formula of the gradient is rise over run. So when we're given the angle, we can apply basic trig to find our gradient, right? So since tan theta is equal to opposite over adjacent, it's equal to rise over 1, which is the gradient, which I'll give you an example of now. So find the value of tan theta from the following. Okay, I'm going to give you a sec to try this one on your own. It is something that we went over in year 10 and possibly again already in year 11. So hopefully this is just revision for you, but if not, I'll go through how to go do this again. If you need a little bit more time looking at my previous slide, you can actually find the download of the slides, I think to your right. Your right's that way, isn't it? Oops. Okay. Hopefully you've had enough time to give this one a go. But let's take a look at this. So the gradient of the function is just it's just the coefficient of 2. So the rise over run is equal to 2 on 1. Okay, so tan theta will be equal to 2. Theta will be tan inverse of 2. Make sure that you're in degrees and not radians like I am. And we'll go shift tan 2. And my angle of elevation will be equal to 63 degrees 63 degrees if you're rounding to degrees. I'm going to round to minutes, so it'll be 63 degrees and 26 minutes. Okay? To the nearest minute. Okay? Or, well, technically, I didn't even read the question properly. They just want the value of tan theta. My actual answer is just this. Okay. Cools. now let's go into a little bit more of the definitions of what we've gone through in maybe year 11, sorry, maybe year 10 for some of you guys. I know some year 10 schools just don't teach everything that they should. I don't know. But basically, the gradient of the tangent is equal to the gradient at the x coordinate at which the tangent intercepts with the curve. Okay, that's like the definition of the tangent's gradient. So the gradient of the normal is actually equal to the negative reciprocal of the gradient to the tangent. Okay, so from year 10, you'll know that if two lines are perpendicular, then m1 times m2 is equal to -1, aka mt times mn is equal to -1. Therefore, oops, that's a big M. I want a small m. Mn is equal to -1 on mt. Okay? That's a rule that I want you all to write down. So I'm going to give you 5 seconds to write that down. 5, 4, 3, 2, 1. Okay, hopefully you've written that down. Okay, cool. Yeah, so in order to find the equation of the tangent or normal of a curve at a specific point of x, we have to use something called the point gradient formula, which I hope you guys already know, is y minus y1 is equal to m times x minus x1, where m is the gradient and x1, xy is the coordinates of like a specific point. Okay? I think I have, oh, I've got the steps to work through it first. Okay, so let's do the actual methods. So the first thing that you need to do is to actually differentiate the curve, okay? From there, you're going to find the tangent at the, like a specific x coordinate. So you're going to sub in, so you find y dash, you're going to sub x is equal to, I'm going to call it x1, into y dash. Okay, your next step is to sub x is equal to x1 into y to find oh, to find y1, and then you're going to use the point gradient formula to obtain the actual like equation to the tangent slash normal. So y minus y1 is equal to m x minus x1. Okay, so here is a question. I would like for you guys to try this on your own. I'm going to give you quite a few minutes to try it. So find the equation of the normal to the function y is equal to x cubed plus 3x squared minus 12x plus 1 at x is equal to 2. If the gradient of the normal to the curve y is equal of the curve f of x is equal to 3x squared minus 4x is -1/4, then find the point of contact of the normal. Okay, so that's kind of like the inverse method of doing A. I'm going to give you a few minutes for this. Okay, hopefully everyone's had a start to question one. I'm gonna go through that now, and then I'll give you a few minutes to try B by yourself as well. All right, so I need to find the equation of the normal of the function y is equal to f of x at x cubed plus 3x squared minus 12x plus 1. Okay, um, I'm actually going to take a new slide for this because there's a lot to be done. Okay, sorry, just needed to write it down so I don't forget all the numbers. So find mn of f of x is equal to 2x cubed plus 3x squared minus 12x plus 1 at x is equal to 2. So the first step is to find the gradient function, so f dash of x, which will be 6x squared plus 6x minus 12. Now I'm going to find the gradient of the tangent at x is equal to 2, because that's just the first step to do it. So I'm going to write f dash 2, so I'm going to sub in x is equal to 2. That's just another way of writing it, which is 6 times 2 squared plus 6 times 2 minus 12, which is 24 plus 12 minus 12, which is 24. I'm just going to double check with my calculator just in case I made a mistake. No, I'm good. Okay, so that is the gradient of the tangent. All right, give me a second. How do we recall what the gradient of the normal is from the gradient of the tangent? Did you say that it is the negative reciprocal? So mn is equal to negative 1 on mt, which is negative 1 on 24. Okay, from here, I need to sub in f of 2. So my y coordinate of like my y1 basically from our step 3. So f of 2, actually I'm going to do it on the side over here so I don't confuse anyone or myself, which will be equal to 2 times 2 cubed plus 3 times 2 squared minus 12 times 2 plus 1, which my brain doesn't want to comprehend. So 2 times 8 plus 3 times 4 minus 24 plus 1. Hope I got this right. I got 5. Okay, so now we're just going to sub it into the formula. Y minus y1 is equal to mx minus x1. So y minus y1 is equal to mx minus x1. I'm going to take a sec to just write down all my variables at this point. So my x1 is equal to 2, my y1 is equal to 5, and my m is equal to negative 1 on 24. All right, so y minus 5 is equal to negative 1 on 24, x minus 5, no, 2. I'm going to show you how to do it using the like y is equal to mx plus b kind of method. And I'm going to show you how to do it in the general formula as well. Let's do mx plus b first. Actually, no, let's do general first. Basically, for the general equation, you cannot have a fraction coefficient in front of x, and your coefficient in front of x cannot be negative. So what I'm going to do is I'm going to times everything by negative 24 so that my x is kind of like free on its own. I'm going to show my lines working. Times minus 24 times minus 24, which will get me to minus 24y plus whatever 24 times 5 is, 120, is equal to x minus 2. Now what I need to do is I need to just bring everything over to one side. So it'll be ax plus by plus c is equal to 0. That's like the, what's the word? The structure that it needs to be in. So my x, as I was saying before, needs to always be positive. So everything needs to be brought over to the right-hand side. Your right-hand side's over here, sorry. So it'll be x plus 24, because I'm bringing the 24 to the other side. Why? Minus 2 minus 120. So minus 122 is equal to 0. And that is my final answer using the general equation. Now I'm going to do it using y is equal to mx plus b, which we've got y minus 5 is equal to negative 1 on 24, x minus 2. So I'm just going to expand those brackets. So minus 1 on 24, oops, 24, x plus 1 on 12. I'm going to bring the 5 over to the other side. So it's y is equal to negative x on 24 plus whatever 5 plus 1 on 12 is, 61 on 12. Okay, and that's my answer using the y is equal to mx plus b like formula. Okay, now I'm going to give you a sec to try doing b on your own. So I'm only going to give you like 30 seconds or so. So if you need more time, please pause the video. But if the gradient of the normal to the curve y is equal to f of x is equal to 3x squared minus 4x is negative a quarter, then find the point of contact of the normal. Okay, I am going to get started. Oops. Oh, I need to make more pages. Give me a quick sec. Perfect. Okay. So the question is my f of x is equal to 3x squared minus 4x. And my gradient of the normal is equal to negative a quarter. What is the x coordinate, was it? No, it said what is x1, y1 equals what? Okay, that's the question. And I just need to double check that the actual equation I got right. Perfect. All right, so the first thing that I need to do is I need to differentiate my function. So f dash of x will be equal to 6x minus 4. Okay, now I know the gradient of the normal, which means that I can find the gradient of the tangent, right? Using the same like relationship that I had in my last question, in that mn is equal to negative 1 on mt. So likewise, mt is equal to 1 on mn, which would be negative 1 on negative a quarter, which is 4. Okay, so now I need to find the x value for which my tangent is equal to 4. So I'm going to write f dash of x is equal to 6x minus 4. I'm going to change my pen color so that I can like show my working to you guys a bit better, which is equal to 4. 6x will be equal to 8. So x will be equal to 8 on 6, aka 4 on 3. Okay? So that's my x1. X1 is equal to 4 on 3. Now, unfortunately, that's not my full answer. I need to also find my y1, aka I need the coordinates of the point of intersection. So what can I do? I can substitute my x is equal to 4 on 3 into my f of x function. So what I'll write is f of 4 on 3 is equal to 3 times 4 on 3 squared, not cubed, minus 4 times 4 on 3. Okay, which will get me 3 times 4 on 3 squared, 16 on 3 minus 16 on 3, which is 0. Okay, so my y1 is equal to 0. So therefore, the point of intersection is 4 on 3, 0. And that is my final answer. Okay, so that's it for the actual content for today's lecture. I'm going to spend the next few minutes just going through like general study tips, and then yeah, so I'll spend the next 13 or so minutes on that. All right. So my study tips for you is number one, to ask questions. Best time to ask questions is when they pop into your head. So when you're actually learning the content, but also when you're doing your study, for all of your subjects, this is important. So I personally, on my desk, I have like a bunch of like scrap paper that I've like just cut into like a quarter of a piece of paper, and I just have this big pile that's like next to all my papers, pencils. And whilst I'm writing down like all of my, like I'm working through a question or I'm doing something and I get stuck on a question and I don't know how to answer it, or I am reading the textbook and for chemistry, like I don't understand, um, you know, how to properly balance this specific equation. I'd write down the question or I'd write down the concept that I don't quite understand, and I'd bring it to either my friend or better yet, my teacher or tutor. And I'd be like, hey, I got this question. I don't know how to answer it, or I've got this question that I don't quite understand. Can you please explain it to me? And they will explain it to you. Um, So yeah, there's no losing in asking questions. There's only gaining. Second one is to find questions from a range of sources. So your textbook is lovely, but your textbook isn't the only thing that, like, if you're just using your textbook, or if you're just using past papers, or if you're just using one single resource, you won't be properly prepared for your prelims and especially for the HSC. You do need to find a range of resources. Your textbook obviously is one. Past HSC papers and trial papers, absolutely another. So past HSC, you just use the NESA site and just search up, 2021 HSC Maths Advanced. You'll find it. Trial papers, there's a few websites. There's like ACE HSC being one of them, and a few others that I can't think of off the top of my head. 8 Minutes topic test is also really good. So I personally, because I did tutoring myself at TuteSmart in Year 12, I had access to Ed Unlimited. So I really took advantage of that fact, and I did use all of the 8 Minutes like text guides and topic tests. So from a student perspective, I can tell you that it's definitely worth the subscription, even if you're not like a TuteSmart student. Um, Another one that I discovered maybe a week before my trials, not my trials, sorry, my prelims, was the Cambridge checkpoint like booklets. So they're like an A5 booklet, and they pretty much have every single past HSC question on a topic, and it's like specific, like topic specific. So it'll have chapters, and it'll be like chapter one, it being whatever some specific like module is, and it'll just have all of those. So I my local library was lucky enough to have a lot of these. So for year 11, I just did it for physics and chemistry because that's what my school had. Sorry, my library had. And then year 12, they also had one for maths advanced, which was pretty good. So unfortunately, by the time you do practice questions like that, you'll probably already know a lot of those questions. So it's not worth buying. But if your library has it, it's definitely worth taking a look at. Um, make your own formula sheet is a massive good one. So another thing that I didn't really mention at the start of the Q and like frequently asked questions was what was it? Oh yeah, what does studying for maths advanced look like for me? Something else that I do typically at the end of a month or at the end of like a chapter in my textbook is I would have a single piece of paper. So, oops, double-sided lined piece of paper like so. And what I would do is I'd write down any like specific key points that were like the biggest takeaways of the module. And then the back side of the paper would be every formula that is relevant to that module. And then I would highlight the ones that aren't on the form. Well, I'd have like a color code system. So one color would be that they are on the formula sheet. One color would be that they aren't on the formula sheet, but like it'll probably be given to you or like it's kind of easy. And then my other color, which is normally like red or pink, that would be it's not on the formula sheet and you are like expected to know it. So for example, for calculus, from what we've learned today, the only two rules that you don't have on the formula sheet is differentiation by first principles and the gradient of the normal. So the mn is equal to 1 on negative 1 on mt. So my personal advice to you would be try and make that sheet yourself, maybe just based off of what you learnt with me today. And yeah, highlight all the formulae that are in the formula sheet one color, the ones that aren't in the formula sheet in another color, and the ones that you reckon will be a bit more difficult to learn in red or pink or something, okay? And my fourth tip, I've got more tips after this, but my fourth tip is to be consistent. And that is the biggest tip I can give you because maths is a skill. It's a skills-based subject. So what's amazing about maths, especially when you're getting towards the HSC, is that the closer you get to exam time, the less you actually need to study for it. It's something that you can, neglect's a strong word, but it like kind of let go of a little bit because it's a skill, right? So if you don't play soccer for a week, the next week you'll still be pretty much just as good, right? If you've been practicing for, months on end beforehand. Um, maths, I know it's such a weird analogy, but it's just like playing soccer. Like the skills that you gain after a week's time won't really be any different if you've been practicing for months or years in advance. So when it comes to exam time, um, you will definitely be very glad with yourself if you've kept up with your homework, if you've kept up with, at the end of every module doing your little like sheet or doing like what I was doing at the end of each week, going through what you learnt this week and what you found hard the week before and what you found hard all year so far. So just being consistent. So practice, practice, practice is definitely the biggest thing. Now, another thing that I want you to take note of is that there is a little bit of like almost a bell curve to the time taken on a subject and the actual mark that you receive. So, yes, I want you guys to work hard, but also I don't want you guys to burn out. That's one thing that you probably hear a lot about burnout. It's definitely not something that you want to experience. But you can see that obviously putting in a little bit of time or a little bit of effort will barely make a difference. Once you start putting in the time and effort, you'll definitely see literally exponential growth. But if you overwork yourself and spend heaps and heaps and heaps of time on maths or chemistry or English or physics or whatever, um, you'll come to a point where you plateau and you start going down. So you need to basically find the perfect, like the perfect effort and time needed to get to this section right here. And that will be different for each and every one of you. Some people have, really high stress threshold and thrive off stress. Others, like me, I get the best results out of being consistent. So I'm not telling anyone to study last minute. You will not do well if you study last minute, um, because you just like once again, especially for maths, it is a skill. It is something that you can't just rote learn the night before. So make sure you invest the time. Just don't invest too much time. Okay. Um, and as I was saying before, practice, practice, practice. Most important thing is practice, practice, practice. Find a bunch of resources, keep going at it, and practice will make, I can't say perfect, but near perfect. Okay. And my last tips for you during the exam would be use your reading time to your advantage. There's so many people, I feel like it's almost 50% of us that will just spend the 10 minutes doing multiple choice. As nice as multiple choice is, my like advice to you is to skim through the whole paper. Take a look and be like, oh, that question over here in page 12, that's kind of hard. And oh, we're going to need some extra time on question 16. Then you go to the last question, you're like, oh, that's gross. So take a look at each question really fast and be like, oh, I might need some help here, here, and here, just so that you kind of have a mental map of where you might need to allocate more time. So, that number one, you don't run out of time during the exam, but number two, um, you are kind of prepared for what kinds of questions you're going to be asked. And then, if you have more time, do multiple choice or do one of the harder questions that you like found. But I feel like the harder questions might be a bit hard because you need to like write, which reading time you can't use your pen. So do whatever you can. My next tip is for mark maximization. Never leave a question blank, like your answer blank. Especially multiple choice, you have a quarter chance of the right answer. But even if you like write down a little bit of scaffolding, write down an equation or two that might be relevant, you've got the chance of getting 1 mark out of however many there are. So write something rather than nothing. And going more into mark maximization is following the framing technique that I was talking about earlier in today. You can read the slides, you can download them and like write them down. Third one is to have faith in yourself. You definitely know more than you think that you do. I don't know, it's just something that the brain does that like always underestimates your ability. So you've done the hard work, you've done your practice, at least I hope you have. And once you get to the exam, you've just got to do it. You've done everything that you need to lead up to it. Okay, and the last thing is to breathe. So many people they'll like hold their breath during like especially during the reading time. People like stress out and they're like, don't be like that. So take a second to like. For me personally, the very end of my reading time, if I did have spare time, that last 30 seconds, I'd close the book. I'd actually close my exam paper, close my eyes, and just take a few deep breaths. That I don't know, that always cleared up my head, and stopped the nerves. So it's something that I have been advised to do, and I also advise for you to do. So that's it for today. I really hope you guys enjoyed this lecture. Please let me know down below what you thought. If you have any suggestions, we are new to this whole pre-recorded lecture thing, so any suggestions will be taken, and we love your feedback. So thank you so much for today. I will hopefully see you next holidays in the June-July lecture series. But until then, I wish you all the very best for the next term coming up, and make sure you enjoy the rest of your holidays. Okay, thank you. Bye.